Welcome to part 2 of Writing Better Code with Reactor 3. In part 1, we mentioned that nothing happens in the publisher until you subscribe to it. This is not strictly true. Broadly speaking, there are two types of publishers. Co-publishers, which starts anew for each subscriber. Examples of co-publishers include requests to external web APIs and to databases. And hot publishers. The data is generated independently and shared between subscribers. Let's continue with the project from part 1. In the pom.xml, we've set the Java compiler to version 8 and included dependencies for Reactor Core, Reactor Test, and JUnit Jupyter API to run the test. Let's quickly set up the test class and test method. The simplest hot publisher can be generated using the just factory method. Let's extract the data generation so we could observe its timestamp using instant.now. We also timestamp the start of the execution for comparison. We extract this timestamp into a method to make it consistent. Now let's add a delay with a subscription to differentiate it from the publisher creation. You can see that the data is generated just after the start of execution at the creation of the publisher and not at its subscription. Now let's add another subscription and another delay. You can see that the data sequence is generated once at creation and used with every subscription. Let's now use Flux instead of Mono and see what happens. Running the test again, we can see that in flux.just, the data is generated at creation time just like mono.just. The simplest way to convert a hot publisher to a cold one is to use the defer method. The defer method requires a publisher supplier. In this case, we'll provide a lambda that returns a mono. Now the data is generated for each subscription. Defer works the same way in Flux. In contrast, the Flux interval method is a co-publisher. You might recall that the interval method generates a sequence of longs starting from 0 at a regular specified interval. Let's print out each sequence with timestamp to observe it. We also print a number prefix to identify the subscription. We'll need to use a sleep after the last subscription since the execution does not wait for the subscriptions to complete. From the printout, we can see that each subscription gets an independent data stream. The data is generated anew with each subscription, not at creation time. One way to convert a cold flux to a hot one is using the share method. Data generation is started at the first subscription to a shared flux, and subsequent subscription shares the same data stream. To let new subscribers see previously emitted data elements, we can use the cache method. As you can see, the previous data values are replayed for the new subscriber. We can also specify the limit to this cache either by maximum history, the duration, or both history and duration. Note that cache should be called after share and not before for it to work. The shared flux is discarded when the last subscriber cancels, and it restarts for subsequent subscribers. We can show this by using the take method, which cancels the data stream after receiving n elements. As long as there is more than one subscriber, the data stream is not discarded or restarted. Another way to turn a cold publisher to a hot one is through the publish method. This returns a connectable flux. ConnectableFlux is not started by subscriptions. Calling the refCount method on a ConnectableFlux returns a shared flux. So publish.refCount is equivalent to calling the share method. Like with the share method, the flux is restarted when subscriber count falls to 0. You can also specify the minimum number of subscribers for data generation to be started. So if you say 2, then it requires 2 subscriptions for the data generation to start. New subscribers will get the same data stream that's generated. Note that when the number of subscribers fall below the minimum subscribers, the stream is not discarded as long as there's any subscriber on the stream. You can also specify a grace period before the flux is ended and restarted when subscriber count goes to 0. Let's return to the ConnectableFlux. We can also start the ConnectableFlux by using a connect method. Note that the data generation is independent of the subscription. It starts at the connect method and not at the first subscription. We can also make the connection dependent on subscribers by using the auto connect method, which turns the ConnectableFlux into a flux. Note that the subscribers have to subscribe to the resulting flux and not to the ConnectableFlux for this to work. Without a parameter to auto connect, the first subscriber will connect the flux and start the data generation. Once connected, it doesn't disconnect even when the last subscriber leaves. Like the refCount method, you can also specify the minimum number of subscribers before the connection starts. In this case, the connection starts at the subscription of the second subscriber. That ends part 2 of this tutorial. If you find this useful, like, share, and subscribe so that more people can find it. Thanks for watching and happy coding.